الثلاثة الماضية، واليوم حيكون إن شاء الله نصيب ال FMS من البيوميديكال البيوميد ستاندردز بلس اليوتيليتي سيستمز إن شاء الله. وحنخلي بإذن الله السيشن خاص بالميديكال جاز لأهميته الحقيقة، فعملناها ببرزنتيشن مستقل مختلف عن البرزنتيشن الحالي. I would like to welcome everyone for the third day, and hopefully you have spent a joyous 3 days. Today we are going to talk about medical equipment, utility system, and I have prepared a dedicated presentation for the medical gas, for the importance of medical gas. So it will be a different presentation, independent presentation. I would like to draw your kind attention for the Q&A. Please do not send any technical questions, because this presentation is not a technical. It's only we will talk about how to administer biomedical standards of CBAHI. So it's an administrative session, not technical. If you have any technical, please address it to your biomedical engineer or to the agent or contractor, etc. And this is just to save the time. However, medical equipment what are standards? Actually, here in this slide, Mr. Koch in 1991 has presented this slide to explain what the meaning of the standard. He identified it as a choke that prevents the quality of service ball from rolling back. And as you see here, that standards have a minimum and optimum limits, but we should not go back within behind the minimum. Generally, the FMS task force or team consists of the engineering, safety, and security. And once we say engineering, we mean the biomed and the utility systems engineers as well. The electromechanical, the people who are working in projects, architects, consultants, etc. So these three teams, engineering, safety, and security, will come together supported by 4 Ps. And the 4 Ps we mean the policy, procedures, plans, and programs. An example for 4 Ps, policy and procedure, like lost and found policy, patient belonging, child abduction, non-smoking policy, cell phone, restriction of extension cables, medical equipment. For the plans, we have the major disaster, internal, external, waste management, and program. First of all, the safety program, hazmat program, and training program as well. So we are here today to discuss and talk about FMS 25 to 27, 3 standards related to biomedical. I will refer to WHO, the World Health Organization, to make some definitions, which mean starting from medical device. That means an instrument, apparatus, implement, machine, appliance, or software for one or more of the specific medical purposes of like diagnosis, prevention, monitoring, treatment, or alleviation of disease, or maybe for investigation, replacement, modification, or supporting or sustaining life, or control of conception. And here we have listed some standard or organizations for healthcare technology like ISO, AC, and FPA, the AAMI, ECRI, OSHA, and WHO, of course, and we have some international and local organizations like Saudi FDA, like CBAHI. Actually, I have found a very simple and clear definition for the medical equipment maintenance, as it was identified by WHO as a set of activities that conducted to keep a medical device in good working conditions and consist of inspection, preventive maintenance, and corrective maintenance as well. If we want to get more details for kinds of maintenance, so we start from reactive maintenance, and actually we call it correction maintenance or corrective maintenance. It's a task performed to identify, isolate, and rectify a fault so that the failed equipment, machine, or system can be restored for an operation condition. And the preventive or proactive maintenance, actually, we have two kinds of proactive. It's preventive and predictive. The preventive should be identified by date as per a specific criteria, while the predictive is a proactive action by biomedical or clinical engineering to do the maintenance. Measurements and test equipments like tools, devices, or system used to calibrate and certify and measure data to verify conformance to specified requirements. Calibration is a corrective action based on comparison between known measurements and the measuring using your instrument. And actually, I get this simple definition for the biomedical or clinical engineer from Duke University. The biomedical engineer is a professional who supports and advances patient care by applying engineering and managerial skills to healthcare technology. And recently, actually, most of the people prefer to call biomedical engineer as a clinical engineer, because most of our engineers, mashallah, they are biomedical engineers, and they have the managerial skills to administer the department. So last days, we started to hear clinical engineering, which is more general. From previous presentation done by our colleagues in CBAHI, I found this slide done by ICRI, and you know the head office of ICRI located in Dubai, and they have counted top 10 technology hazards. For instance, inadequate cleaning of flexible endoscope before disinfection can spread deadly pathogens. Missed alarms can have fatal consequences. Insufficient training of clinicians on operating room technologies puts patients at increased the risk of harm. Even in radiology or nuclear medicine, like gamma camera, mechanical failures can lead to serious injury of death. I'm not going to count one by one. Some photos regarding hazards, like cross-contamination from flexible endoscopes and misdiagnosis due to equipment inaccuracy. In this slide, we are seeing medication administration error when using infusion pumps. And the next one in radiology, exposure dangers from radiation therapy and CT. We have 3 standards in CBAHI related to medical equipment. We will start from 25. The hospital has a biomedical equipment plan to ensure that the medical equipment are regularly monitored, maintained, and ready for use. 25.1, adequate number of qualified biomedical staff. Qualified mean we have to check the personal file of biomedical engineer or clinical engineers. Actually, there is so many approach to estimate the required number of individuals, engineers and technicians. The first one, we have two approaches. Actually, it doesn't mean that another approach is not correct. So for instance, we assume the typical staff on average is 2.5 technician per 100 bed and one clinical engineer for 3 to 5 biomedical technicians. Then we should have one admin for 5 to 7 staff. This is a general estimation, actually. I think we got it from ICRI, and I remember that our colleague, engineer Jaman Al-Amri, who is our colleague in CBAHI, is FMS surveyor in King Abdullah Medical City. He has an estimation done during his master degree. However, an accepted ratio would be approximately per 500 assets. I mean, one engineer per 500 assets. In addition to that, actually all these numbers, we will check it in our visit during department staffing plan document review session. So we will look at and to make the necessary comparison. 25.2. There is a written biomedical equipment. Covers the following: the inventory, comprehensive inventory, the PPM program based on certain criteria, frequency of check, method of check. A program should include the process for investigation, how to follow up, how to receive it from the warehouse, to putting in end user and the training criteria. Then should include the electrical safety testing, electrical safety, then the history record for the maintenance schedule. Actually, during our visits in hospital, we find these items from 1 to 6. We couldn't find it in one policy. So please do your best and save the time of your department and the surveyor time and put it in one plan. Inventory is very important. During the unit visit, the surveyor will collect 5 inventory number for 5 assets. Then we will meet with the technicians in the workshop, biomedical workshop, asking them about the number we have collected during a unit visit, and they will give us the full details about these assets. We mentioned the inventory. The inventory should have a certain data. The data could be identified by the following: the identification number, type of equipment, brief description of item, manufacturer, the model number, serial number, physical location within the facility. If you remember, yesterday we have count the safe operation pillars, and one of them was how to monitor and track the biomedical equipment. That's why physical location within the facility is very important. And the technician or the engineer in the workshop, once we give him or give them the ID number, he should locate the equipment. The data included should include as well the condition or operating status, or requirements, operation service requirements, date inventory updated, maintenance service provider, purchase supplier, or another info as needed. Actually, I got this slide from the website of World Health Organization describing all the process required by clinical engineering department, the regulation, the policies, how to make assessment and management of the assessment for the equipment. Actually, we strongly recommend that hospitals should have a CMMS. We found some hospitals have only an Excel sheet, just counting the number of assets. Unfortunately, it doesn't give you the facility how to administer the equipment, especially if you have 12,000 equipment. It will be very difficult to administer and follow up. However, let's identify or explain the definition of CMMS, Computerized Maintenance Management System, as a software package that maintains a computer database of information about maintenance operations. Once you have an automation system, it could give you the following. It is your work as a clinical engineer. It will give you the inventory management of equipment and spare parts. It will give you the corrective maintenance, including all phases of work order, PPM, follow-up, other elements like needs assessments, donated or procured equipment, as well as equipment placement. Here I have listed a chart for a work order module that can be followed. And I have marked that CMMS here will play a major role, starting from the equipment fault, how to receive the call, how to transfer the order, and how to close it. And if you have it and you have spare parts, or you don't have, or you need to make a purchase order or not. FMS 25.3 and 4, talking about the technical service manual and operator manual. Both should be available. The first one should be available in the biomedical workshop. The operator manuals, copy of it should be available in the departments. We don't stipulate to have a hard copy in departments. If you have a soft copy, it works. It's okay. No problem at all. The hospital ensure that all maintenance work are conducted by qualified and trained staff. Actually, this activity we call it personal file. We open the file and we should find a certificate of attendance on high-risk equipment from agents. Actually, here we are not talking about the end user. We are talking about the biomedical and technicians of biomedical. Especially for high-risk equipment, we should have a certificate of attendance in their file. And equipment maintenance and repair should be documented from the date that you have entered the equipment to the hospital. 25.7, investigation procedure conform to manufacturer instructions. Actually, here we are comparing some corrective action taken against medical equipment failure. However, PPM frequency usually based on certain criteria. The major criteria related to manufacturer recommendations, risk level of the device, and load of work on the device. If you have force one, it's okay, you are welcome to add it. And the last one is there is an equipment recall. And here we emphasize and we stipulate that every hospital should have a liaison officer between the hospital and Saudi FDA. This is to ensure regular communication between both sides. This should be from hospital to Saudi FDA and from Saudi FDA to the hospital. Anyone can make participation through email, and we recommend that the officer should be Saudi to ease the work and paperwork with Saudi FDA. And at the end, we have to check the personal file to find that someone from the medical department really is doing this duty as a liaison officer. Actually, during our visits, The hospitals that are meeting this standard are only a few, where we should have that each department has a backup or alternative for each critical equipment to cover for prolonged downtime. For instance, actually the high risk or critical equipment, as per WHO, its categories, it's 6 equipment, as I remember, like anesthesia machine, like infusion pumps, defib, etc. And this slide, I would like to show you that it's a sample document got it from a hospital during our visits. Here, the backup related to anesthesia machine, the location, and the backup whether available or not, or ready to use or not. Usually, this kind of backup location could be in the OR, ICU, dialysis, ER mainly. As a document review, we have to see this list, and an observation, we have to see these machines in the store, the sub-store of these departments. Preventive maintenance data are used for upgrade and replacement, where we statistical report generated from the maintenance management system and the action taken. And that's why to have a CMMS is vital to procure or to produce such statistical studies or criteria. An example should be available during our visit to the hospital, preferably 3 examples. There's a policy to perform inspection on all new equipment before commissioning, including those brought for them. This is a dedicated policy. However, we should have a written policy for the tagging. The tagging may differ between 4 to 7 tags. It's unlimited and based on hospital policy, like the PPM, the inventory number, the serial number, removal from service, electrical safety check. And we give attention especially for the defective equipment that should be in red color and not less than A4 size, that this device is defective, please don't use. We should have policies for removal equipment, التكهين, سياسة التكهين, or to address agent or to contractor for repairs, how to eliminate the use of extension cords, and policy to restrict use of cellular phone, especially in critical care areas, operation theater, and cardiology unit. This is one of sites we have seen during visits. Under the counters, under the desk, and the reception desk, especially in nurse station, we have to avoid such issue. Hospital staff are trained to operate safely all medical equipment, and this should include the physician, nurses, and paramedics, who are included in this training session. The new ones were receiving new equipment, staff transferred from a department to another, recurrent of misuse equipment, and foreign new staff. And we have to see the training certificates in the department we visit. It's like ICU, like dialysis. We check the surveyors will check the competency list of nurses and the training sessions or certificate of attendance. All training records must be kept in departments, and in biomedical departments, it's optional, but in each department, we have to see it. Actually, before 10 years, once we visit hospitals, asking them about how do you grouping the biomedical equipment, the answer was group ABC. A was related to that this equipment will be maintained and repaired by manufacturer, while Class B or Group B maintained, repaired by supplier. Group C maintained and repaired by biomedical engineer. Actually, this philosophy was changed more than 10 to 15 years after the biomedical engineering faculties was established in the kingdom, and start to graduate biomedical engineers. And that's why now the new era of classification, the equipment became the low risk devices, medium risk, and high risk devices. High risk devices like life support devices, therapeutic and diagnostic, whose failure or misuse is likely to cause injury and have an impact on patient care. Medium risk devices where failure or misuse or absence is not likely to cause serious injury. The low risk devices, failure or misuse is unlikely to result in injury to patient or staff. Actually, before ending the session of biomedical, I have remembered that we got questions and answer from ASHI, American Society for Healthcare Engineering. I encourage and foster every one of you to be member of that association. We are getting all communication done by FMS managers or individuals over all the United States. And one of them, I remember, it was within the question was, within the last 12 months, has anyone documented and reproduced a cell phone causing interference with a medical device? And the question was as follows. The Mayo Clinic published an article, cellular phone interference with medical equipment, that reported, or of course, after testing 15 devices with 6 cell phones, they found clinically important interference of 1.2%. And as I remember, it was in telemetry. However, please, I just foster clinical engineers to take care of mobile phone network and its effects on their equipment, and to prove it by evidence. Mr. Abdul Mohsen, I don't know whether you have an interference or comments on biomedical, or you have any question.
Thank you so much. I would only be summarizing, if you allow me, the points that you have addressed in this regard, and I'll try to mix it Arabic and English.
Okay.
طبعا الهدف من برنامج خطة المعدات الطبية هو أن نحرص على أن تكون المعدات الطبية المستخدمة في المستشفى تكون لدينا بشكل آمن وسليم ولا يشكل خطر على المستخدمين واللي هم البيشنت، وأن الأشخاص الذين يعملون عليها لديهم المعرفة التامة بطريقة الاستخدام السليمة لهذه المعدات. من أهم النقاط اللي أوردها المهندس نوار في محاضرته اللي هو موضوع أنه يوجد لدينا خطة لإدارة المرافق، لإدارة المعدات الطبية، ويوجد لدينا حصر بالمعدات الطبية وأماكن وجودها. للأسف الشديد في أماكن كثيرة تجد هناك معدات مغيبة ومعدات وردت ومعدات لا يعرف أين هي، مفقودة بسبب عدم وجود عملية جرد سنوي ومتابعة لعملية تواجد المعدات الطبية وتوفرها بالعدد الكافي. لابد يكون لدينا في المنشأة عدد كافي من المهندسين المؤهلين، فيتم التأكد زي ما ذكر سعادة المهندس نوار أنه والله يتم التأكد من هذا الأمر، أنه يكون عندنا عدة معادلات أبسطها أو المستخدمة الموجودة في المعيار أن كل 500 جهاز طبي عندنا مهندس يستطيع العمل عليه. طبعا المعدات الطبية تصنف ومش كل معدة طبية موجودة يتم صيانتها من قبل مهندس موجود في المنشأة. في معدات حسب التصنيف حقها يكون صيانتها من خلال إما الشركة المصنعة أو وكيل مرخص أو من خلال المهندسين مدربين في نفس المنشأة. تدريب وتأهيل العاملين سواء الموظفين الجدد والموظفين المنتقلون من إدارات إلى إدارات أخرى، المعدات التي يكثر فيها الإعطال أو عند توريد معدة جديدة، هذه كلها من الأمثلة. من الأشياء الرئيسية اللي ذكرها المهندس نوار إن والله كيف نتعامل مع المعدة الجديدة. وتعريف المعدة الجديدة لا يشمل فقط المعدات المشتراة، ولكن أيضا يشمل المعدات المنتقلة أو المأخوذة على سبيل الإعارة أو القادمة من مستشفيات أخرى أو القادمة من جهات أخرى. يشمل كذلك المعدات الطبية التي يملكها المريض أو قدم بها المريض نفسه، فلا بد أن نتعامل معها بحرص وبحذر شديد بحيث لا نقع في إشكاليات أو لا سمح الله تغير التيار الكهربائي أو إلى من هذا القبيل. وهنا يأتي دور الأمن. السياسة هذه تحديدا لازم يكون الأمن فيها دور، ولأن الأمن هو الذي مفترض أنه يكون سيف كيبر، يعني يمنع دخول أو خروج المعدات الطبية، يمنع دخول المعدات الطبية من خارج المنشأة دون مرورها بموافقة واستلام الهندسة الطبية، ويمنع كذلك خروج المعدات الطبية بدون إذن مسبق. من النقاط الأساسية اللي ذكرها سعادة المهندس نوار اللي هو موضوع الفحوصات ووجود الملصقات ووجود ملصق الجرد السنوي. السلامة الكهربائية مهمة، لازم نمارس السلامة الكهربائية، وعندنا معدات فحص للسلامة الكهربائية اللي نسميه الإلكتريكال أنالايزر. أن الجهاز هذا نفسه اللي نعاير به لازم يكون معاير، لازم يكون كالبريتد. لابد أن يكون لدينا سياسة لمعرفة العمر الافتراضي للمعدة ومتى نخرجها من الخدمة. المعدات التي تتجاوز عمرها الافتراضي، المعدات اللي هو اللايف سبان حق المعدة الطبية، أو المعدات التي أصبحت تكلفة صيانتها تزيد عن نصف تكلفتها، هذا يفضل استبدالها لأنها لن تكون مجدية اقتصاديا. المعدة التي تم طلب استدعائها من الاس اف دي اي او من المورد، او لم يعد هناك دعم لها او توفر قطع غير، هذه كلها معدات لابد يفكر المستشفى في كيفية إخراجها. الإخراج لهذه المعدات لازم يكون آمن وسليم، خاصة المعدات التي كانت تستخدم الكونتامينيتد الملوثة أو كانت مستخدمة لعلاج أمراض معينة أو مرضى معينين، ويخشى من انتقال العدوى في حالة عدم معالجتها بالشكل السليم. لابد يكون لديك سياسة لحفظ هذه، وهذه من المتطلبات اللي ذكرها الباشمهندس، إن لازم يكون عندنا سيف ريبريزنتيف في المعايير تبع الليدرشيب من المنظمات تطبق هذه الاشتراطات. هذا بشكل مختصر شديد اللي هو النقاط الرئيسية اللي تفضل فيها المهندس نوار. Thank you so much, Engineer Nawar, for giving me the chance. Thank you.
Okay. Thank you so much. Utility system. Since we are talking about FMS, and assume that all FMS individuals are watching us, I would like to draw your attention for a vital challenge, a question, which is how safe is healthcare? Do you know that there is 100,000 deaths per year in hospitals, staff and patients, acquired patient in USA? And once we say staff, it's not only doctor and nurse. We mean maintenance, housekeeping, and anyone of staff. And do you know what the meaning of 100,000 deaths? It's like if we, Allah forbid, get 20 airplane crash in a week, every week. Just imagine if every week we are getting airplane crash 20 times a week, this is equal to 100,000 deaths. So the question here, as a staff, do we have a choice? We don't have a choice. Can we prevent it 100%? We cannot. So what is the solution? We talked yesterday about the risk assessment. So we assess risk, then we control the risk. Because based on the evidences and experiences, if we had a good design or construction, we reduce risk at 20%. Just imagine, in construction and good design, very proper design, if we share every single expertise, we will reduce the risk only 20%. Okay, what about the 80%? It's coming from good operation. So this is our duty in FMS. We are the people who are running the show, of course, non-medical show, I mean, in the hospitals. Imagine that 80% we reduce the risk when we operate safely and in a proper way. Utility system from 28 to 39. What is the utility system? We have so many systems, including in these categories like the medical gas system, like a fire sprinkler system, along with the piping, pumps, tanks, heating, ventilation, AC system, all component of AHUs, chillers, tank unit, etc. All these components a part of the system, and the power system and the emergency power system as well. Of course, we have the other system like the elevators, the paging system, etc. Once we start the biomedical presentation, we count some references. Okay, here in a utility system, let me count the following references. I will start from guidelines, which is FGI, from the Facility Guidelines Institute. It's a very important reference where you can find some architectural and somehow civil comments. ASHRAE is the only reference that we have, talking about electromechanical, especially for ventilation of healthcare facilities. Once we say ventilation, the air change per hour, the temperature, the humidity, relative humidity, etc. And OSHA regulations. If you have a project, construction project within the hospital, it's not to depend on infection control department to tell us as engineers what to do. So you can refer to the CDC, where there is a dedicated chapter for construction in healthcare institutions. We have NFPA, National Fire Protection Association. Locally, we have MOMRA, the Ministry of Municipal and Rural Affairs, وزارة الشؤون البلدية والقروية. We have civil defense guidelines, and we have recently called البناء السعودية, the Saudi Building Code, which became mandatory since Muharram 1440 Hijri. However, let me introduce to you the facility guidelines for KSA. This one. This reference or guidelines, we worked on it since 3 to 4 years. Meetings with the Australian firm to produce healthcare facility guidelines instead of using the FGI, this one. We have produced this one to be used in KSA. However, it's completed actually, but now there is a ongoing communication between CBAHI and Saudi Building Code to be a referral in Saudi Building Code, or even to be mandatory even, where we have include all criteria from design to operate the healthcare institutions. So simply, as we have mentioned, the kind of maintenance, also here in facility utility system, we have two kinds of maintenance. we have the planned maintenance utilities, and we have emergency response to failure. Starting FMS 28, the hospital has adequate number of qualified staff. If you remember, in all maintenance, even in biomedical, we are looking for qualified. So qualified staff is very important. Qualified means we check personal file to make sure that our engineers are registered in Saudi Council of Engineers. We cannot accept that there is maybe foreign engineers from the contractor who is engineers in reality, but he is here in the country as a labor or a housekeeper. Absolutely, we cannot accept it. So he or she should be registered with the Saudi Council of Engineers. 28.2, utility system management plan that include management of failure or interruption. So from normal power to the emergency power, elevators, boiler, etc., fire alarm. We should have a plan B or alternative solution for each system from 1 to 13. The action and the procedure, how to do it in details. If you have forms for that, it's recommended to attach it with the plan and make the pages number in accordance with the policy itself or the plan to be a part of the plan. Utility system management includes description of necessary hospital program, 28.3. Actually, here we request hospital to describe how the facilities conditions through PPM or corrective maintenance data are assessed and set the time frame to replacing or upgrade. Like we can prepare a table, schedule of list of items, mention the project, the location, the estimated price, and the time frame. This should be identified in this standard. The second one, 28.4, talking about the drills, test or simulation at least once a year. You remember how Mr. Abdul Mohsen explained how to conduct drills, fire drills. Here also we should have drills similar to the fire drills, but this time is related to utility system. We'll assume that we have a scenario like today, guys, we don't have medical gas. Suddenly, the network of medical gas collapsed. So what is the scenario? What is the action taken? All this should be documented once a year for each system of utilities. This is a document as a document review. But in observation, we have asked the staff to assess their knowledge how to act in case of failure or during or different scenarios. The utility system should ensure availability of the following: technical utility drawings. We should have AutoCAD drawings for all utility systems, starting from fire alarm to suppression system, to electrical to mechanical system should be available and updated. Updated is very important. 28.5, statistical data produced by the maintenance management system as an indicator to evaluate the performance. It's easy again. We should ask our contractor, if any, to count for us, or if you have CMMS for utility system, you can collect all the job orders or work orders received and categorize it. Is it civil? Is it civil? Is it HVAC? Is it maintenance? Is it welder, painter, etc.? And prepare it. And after that, you can evaluate the performance through KPIs like this one, where we compare the job planned by the completed job planned. Preventive maintenance to cover all the following. Here we should see or have utility 52-week maintenance schedule and reports. I have seen in several hospitals, they have prepared in one sheet, A0 size, listing electrical, mechanical, plumbing system for weekly, monthly, or maybe annual maintenance. And as I mentioned before, that qualified technicians or trained technicians should be available, where the hospital should prove that they have minimum 6 months diploma. This is a sample document for 52 weeks. Here, the daily and weekly months. This is the part relative to January. We can repeat it for the other months of the year. Then the equipment should be listed for all electrical system. Similarly, here, the Hvac, we have to include all PPM that should be conducted for the chillers, fan, AHUs, fan units, humidifiers, boilers, refrigerators, of course, walk-in refrigerators, etc. Electrical outlet should be identified for the voltage and for the source. Even the hospital have only one voltage, please remark or label the outlet. If it's all 220, it's okay. Label it. We cannot tell the surveyor that it's okay, it's only 220, I don't have to label it. No, sir, you have to label it. In this attached photo, we have label the essential and or prime location by putting or installing a red color or any color to show that it's connected to the emergency system, the power system. The thermal inspection for the circuit breaker for the following locations: in operation theater, laboratory, critical care, alarm system, blood storage, and medical gas. And this is just a sample photo that we are getting to recognize where the failure might occur. Earthing system. Earthing system, actually, if you remember, maybe we talked about it yesterday or not. However, earthing system should be available, and one of two can prove it. Either the biomedical engineer can measure the resistance between the outlet and the equipment, and to the best of my knowledge, should not exceed 0.2 ohm. Or the maintenance people can prove it if they have a well for earthing full of gravel and coal. Then they put a metallic bar around 10 meters outside the hospital and measure the resistance. I think maximum should be 0.5 ohm. The hospital has emergency power. Cover the following. Of course, here we check the single line diagram to make sure that these locations are connected really to the generators, starting from operating theater, labor and delivery, critical care unit, fire pumps, medical gas system, morgue, emergency room, elevators, escape routes and corridors. All this will be connected. The hospital maintains generators, testing generators. Of course, we have three kinds of testing. We have weekly test with no load, 10 minutes. We have monthly on load test for 30 minutes, and we should perform full load test every 3 years on external load. And of course, once we visit the site, we will ask the electrical engineer, to run one of the generator to make sure that it's really running. Please make sure of the batteries, because there is statistics studies done in USA and UK that 98% of the cases that standby generator doesn't work, doesn't start, and it was because of the batteries, even if the generator is new. Please check the batteries. Check the terminal should be clean, and if possible, you can cover it, especially in case of dust storm. Medical gas, actually, I reserve on it. Here we have 2 slides, but I will go at the end of this session to the medical gas presentation because it's essential ESR, essential safety requirements, and I prefer to elaborate about it. So I will cancel these slides. We'll explain it later on. 33.1 talking about how to handle various types of compressed gases, on how to storing them, how to positioning, how to separate flammable from oxidizing. If you remember yesterday, while talking about hazmat and waste management, we focused on the main role in hazmat storage, and it was how to separate flammable from oxidizers. It was the major or the headline. We have to check the exhaust for laboratory safety cabinet, for central vacuum gases, for scavenging system, and for the BMT laboratory gases. Usually, this exhaust should be located on the rooftop. The height of this exhaust should be minimum from 250 to 3 meters above the floor level of the roof, and to be away at least 25 feet or 8 meters from fresh air supply of the AC. Compressed gas, just a sample we have found in a hospital, actually a remote area hospital, where you can notice the outlet of medical gas, but they have this, I don't know whether it's backup or not, but it's a freestanding, and here the storage is absolutely wrong. It could fall down over the patient. Plus, I would like to mention that bed location is wrong here. As engineers and clinical staff, we should consider that clearance around the bed should be 1.2 meters, 120 centimeters around the bed, and the head should be 35 centimeters away from the wall. Why? This is to ease the work and to ease the maneuver of the crash cart and ease the duty of CBR team, could be. 34.1, here we come to the Hvac. We should have the PPM Hvac trained and supported by qualified. Again, we mentioned it before, the engineers should be registered with Saudi Council. The technician should have a diploma, 6 months, and have enough experience to deal with. We should check the all maintenance record for the Hvac components, and we have to check the maintain and control the air quality in cleaning replacement filters. We should see the schedule and the record of replacement and cleaning of diffusers and ducts. We got a lot of questions asking us about cleaning of ducts. Actually, I have conducted a colleague working in MIH here in Jeddah, and he told me that cleaning of ducts should be conducted once every 18 to 24 months. Once every 18 to 12 to 24 months. HEPA filters are monitored on a monthly basis and the results are documented. HEPA filters location where? We locate HEPA filter usually in operation theater, on the supply over the operation table. We have HEPA filter in procedure rooms, in C-section, in cath lab, in isolation room. We look at HEPA filter on the return, not on the supply, of course, in isolation rooms. We have it in CSSD as well, and in miscellaneous locations. Air change per hour. Actually, our references here is the facility guidelines. They have a chapter retrieved from ASHRAE talking about air change per hour, like this. Here, for instance, critical and intensive care, we should have, let's have operation room, should be positive pressure. We should have a 20 air change per hour, not 100% fresh air, only 20% fresh air. Okay, how to calculate it? In this sample, we get the return measured by CFM, cubic feet per minute. We should mention the total volume in cubic feet of a certain room, then calculate the air change per hour. What the required, what the existing. '35, we ensure the proper airflow, whether positive, negative, or a neutral. For instance, in operation theater, should be positive. Delivery, labor and delivery is not required. I mentioned now the location that mentioned in CBAHI standard. So in labor and delivery, not required, but in C-section, it's positive because here we have open patient. It's an operating room. So it's away from labor and delivery rooms. Isolation room should be negative. Clean and dirty utility. Clean should be positive. Dirty should be positive, negative. CSSD in decontamination should be negative. In sterilization and storage should be positive. Triage in ER should be negative. And waiting area, by the way, should be negative in ER. Trauma area should be positive. It's a kind of minor operating room. And in the laboratory, it should be negative. All the section of laboratory. The people mixed here, they are telling us when visiting the hospital, no, it's only TB lab required from us to be negative. Of course, the answer is no. All the laboratory section should be under negative pressure. In TB room, it should be more negatively, respectively to the corridor. And all laboratory section department should be negatively, respectively to the corridor. So all laboratory should be under negative pressure. The appropriate control of temperature and humidity. Again, I will mention here in the operating and recovery, it's 20 to 24 degrees Celsius. In nursery, please bear in mind, in nursery, from 22 to 26 degrees Celsius. In sterile storage supply, maximum 24. Critical care unit from 21 to 24. And in patient room from 21 to 24. Actually, overall the hospital, we should keep the hospital from 21 to 24. In operating theater, actually, the design parameters is from 20 to 24. However, we call it design parameters. Means if the surgeon demanded from the FMS manager or director to reduce the degrees, the temperature to 16 or 17, it's okay, we have to do it. Because as a clinical services, the surgeon have to reduce the temperature, especially in operation related to orthopedic or cardiology, or maybe in C-section, as I remember. So let's differentiate between design parameters and the actual. Actually, please don't argue with the surgeon. Obey what they need. 37, ppm for water system. And here, actually, in 37.2, we have to test our water once a month for bacterial that could be done internally, in-house, in the laboratory. And we should have chemicals once every 6 months. Chemical test cannot be done in-house, should be via third party. And of course, the water in the hospital should be available 24 days a day, 7 days a week. And we should see a contract between the hospital and a contract for providing the water. Actually, as a matter in fact, once we start our surveying visit in a hospital, we call the facility manager or director to ask him about the capacity that available for the power system, for the water system, for the medical gas. He should present a calculation that this is our capacity, this is our demand, our need, and this is our plan B. If the facility manager doesn't know this criteria, how could he manage the facility safely? He cannot. So please focus on these criteria. Sewage should be handled, and disposal, of course, should be conducted in efficient way. We should see the sewage disposal policy. Actually, if there is a sewage treatment plant, STP, we have to check it. We have to check the grease trap in kitchens, decay tank in the lab, and to check the lab waste liquid sink as well, because it's forbidden in the lab to pour the waste liquid in the sink, especially once the sink the sink is being connected to the municipal line. 39, talking about the laundry equipment and the kitchen. In the kitchen, the hood fans should be in good operating conditions and should be cleaned weekly over the hood, over the oven area. Cold room temperature should be monitored. Kitchen and pantry microwave should be checked as well. In the laundry, if you see that there is a lint in the washer machine, it does mean the maintenance is not doing their work properly, because mint collection here behind the washer machine means that there is a leak somewhere. So please, for those people who are working in laundry, please make sure and inspect it on maybe a daily basis, weekly basis, to make sure that there is no accumulated lint, and call the maintenance accordingly. Mr. Abdul Mohsen, any questions or comments?
Thank you so much, Engineer Nawar. I received few questions regarding the medical gases, but I'm sure that you will be covering it in the upcoming presentation.
Yeah, yes, right.
I do have a question here. If the AC is 100% fresh air, the air change in OR should be 20 air changes per hour, or it can be less?
Okay. Actually, in old hospitals that built in 2001 and before, the facility guidelines or ASHRI was giving the air change per hour 15 and 100% fresh air. Now, since 20 years up to this day, everything is changed. If you have seen all the international and the national references, stipulate to have 20 air change per hour and only 20% fresh air in operation theater. So since 2000 up to this day, should be 20 air change per hour, only 20% fresh air. The other 80% should be recirculated.
Excellent. Thank you. I have a repeated question, if you don't mind. It is related to the staffing plan of biomedical engineering.
Okay.
Can you please elaborate? We put several criteria. One of them is to have an engineer for every 500 bit. Can you please again go back to that slide, or to present for the attendees the number of the staffing recommended?
Okay. Okay, I have mentioned before actually that we have so many references for staffing plan. from ICRI, from European Union as well. And our colleague in CBAHI prepare his MBA or master degree in that field as well. So I mentioned two references here. Staff on average is 2.5 technician per 100 bed. So it's per bed here. So reference is either per bed or per asset or equipment. The first one here, 2.5 biomedical technician per 100 bed, and one engineer for 3 to 5 technicians, and one administrator, or secretary for 5 to 7 staff. You can follow the other one where the base of criteria calculated as per assets. The ratio was 500 assets per engineer. Hopefully it's clear.
Yes. If we can give an example for that, for a 200-bed hospital, based on the example above, you would have 5 technicians.
Right.
And you would have
2 engineers.
2 engineers.
Yes.
So seven staff. You would have one also clerical staff to handle the system, doing the order, the secretarial business of the office. So we will end up with five technicians, 2 engineers, and 1 clerical staff or admin staff.
Absolutely, you are right. And then for the next example, which is by bed, if we have 2,000 assets, it means we should have 4 engineers, because we have 1 engineer per 500 bed.
500 equipment, yes. 500.
Yes, equipment.
Equipment. And yes, usually the equations come also, if you have an engineer, you would be having, along with him, 2 to 3 technicians. Yes, with every engineer.
Absolutely, yes, right.
Thank you so much, Engineer Nawar. I think you can proceed for the medical gases presentation, and if any further questions, it can be also given by the attendees.
Okay. Okay, medical gas. How to comply with CBAHI standard? Yesterday we have said and we have talked about healthcare safe operation pillars from our experience in facility management. So to go home and get rest and sleeping well, we have to keep 3 pillars safe, working and functioning well in our hospital. The first one is fire safety. Fire safety means all the system that mentioned yesterday, starting from smoke compartment to the fire rated to the detection system, suppression system, and evacuation, a proper or safe evacuation. This is all under fire safety. The second pillar was nurse call. The third one was medical gas. Actually, and I have classified in these 3 categories because these 3 have a direct impact on life safety or patient safety. It doesn't mean we don't have different risk. We have it, but these 3 have a direct risk on patients and the staff as well. In CBAHI, we have adopted HTM. HTM is the British standard. It stands for Healthcare Technical Memorandum. Actually, the British standard was established in the 70s. It was dedicated for governmental hospitals in UK. From 70s up to date, I don't think it's developed or updated, and no one adapted internationally. However, some states or countries have adopted certain chapters of provision. One of them is the HTM 0201 related to medical gas. I do believe that British standard HCM, medical gas, and electrical chapter or electricity chapter and elevator is stronger than the American that we know, which is popular. And that's why we have chosen HTM to be our recommendation in CBAHI standards. However, the primary objective in HTM was emphasizing on safe and efficient operation and use. Plus, the philosophy of HTM, and it's written clearly in the introduction that only and only authorized person, of course, PMG stands for piped medical gas. Only authorized person who is operated safely and efficiently. No one can interfere. Usually, in our hospitals, a few years before, plumber is taking care of, with full respect, taking care of our medical gas, which is fine. But those technicians or plumbers should be trained in medical gas criteria because it's so different from normal and regular plumbing works. Plus, only the authorized person can decide that a part of a medical gas pipe system should be taken into or out of use. Only him. What type of medical gas? We have so many types. We have the medical oxygens, nitrous oxide, Intenox, which is 50% oxygen, 50% nitrous oxide. I think it's used in L&D sections. We have nitric oxide, it's very rare. Medical compressed air for both, of course, 4-bar and 7-bar for surgical and respiratory applications. Oxygen, carbon dioxide mixtures, medical vacuum, AGSS, West Anesthetic Gas System, in British terminology, I think, and it's WAGD, W-A-G-D, and in American terminology, West Anesthetic Gas Disposal. What is the basic description of PMG? It's source of supply. Then we have the network, pipeline, distribution. Then we have the terminal units, and we call it AFCU, Area Valve Service Unit. So this is the component of the network, source of supply, pipelines, and terminal. This schematic showing the tanker where we have the delivering the oxygen to the tank, LOX tank, liquid oxygen tank, the plant room where we have the vacuum plant and air compressor, and the manifold where we have the relief, the valve assembly, and we have cylinder bank as well. Now let's come to the most important slide in this presentation, which is the oxygen, because oxygen has a vital impact on patients, especially in critical care area. We should have the following. We should have primary supply, we should have secondary supply, and we should have oxygen cylinder stock. I will elaborate on it one by one. In primary supply, usually we have tank or tanks. Some hospitals, they are telling us that I have primary supply as a tank, and the second one just beside it is it's a secondary supply. No, sir, it's one primary supply, especially when you are making a bypass and put it beside each other. This is one system. However, in the level of oxygen, liquid oxygen in the tank, we have a stock. We should have a level 4 stock and level 4 risk assessed stock, and we can level 4 unusable tank. And this is decided by the manufacturer or by the biomedical engineer that I recommend PMG should be under clinical engineering, because, you know, from our humble experiences, we found that clinical engineering or engineers are more organized and have the academic background to handle medical gas as appropriate. since medical gas is a very important and vital item. However, let's come back to the secondary supply. Secondary supply means manifold. We have right bank and left bank, okay? The most important item here that we should have an automatic switch valve between the primary and manifold. And even within the manifold, we should have an automatic switch or automated manifold, we call it automatic manifold, between right bank and left bank. The automatic switch valve. Why automatic or solenoid valve, whatever you call it? Because we don't depend on a human to open the valve or to open the lever, or maybe he forgot to open it, like what happened in certain hospital. Because in the last 6-7 years, we got 2 painful incidents in medical gas. One was related to unavailability of automatic switch between the manifold and the primary source. The other one related to cross connection. However, the primary source, the secondary source, and the oxygen cylinder stock should be available. Why we should have oxygen cylinder stock since we have manifold and oxygen LOX tank? Actually, this I put intentionally this slide because it's wrong to show you that it's an improper storage. However, why we should have cylinder stock not connected to the manifold? What happened in some hospitals, in some cities, especially after internal disaster, like flood disaster that occurred in Jeddah 2010 and 2011, etc. The supplier of medical gas was not able to provide hospitals with cylinders and oxygen liquid tank for 2 days. 2 days, the hospital stayed without supply. So that's why, if we assume in CBAHI, while putting our standards, the third national standard, we assume that the hospital should be primary source, finished, empty. They are using manifold, empty. We should have storage for the cylinder as a stock. This cylinder should be enough for 48 hours, and we put it as a standard, should be available in our hospital. This is the proper storage actually. It's not necessarily to have a chain for every cylinder. We can construct something like a handle in between and make chains between every row of cylinders. We can have this kind of trolley or holder. What kind of test that should be done over the BMG? We have 4 types. The first one is the cross connection, the one I told you that we got an incident a few years before. The second one is performance. The third test is identity. The fourth is quality. While talking about cross connection, if you have, for instance, 4 lines of medical gas, and you are doing some repair or welding or a new line, so you have to shut off three gases or 3 pipes to test the 4th one. You cannot make the 4 open, close the 3 and test the 4. Then close number 4 and number 3, 2, and test number 1, and so forth. So close the 3 and test the 4th one. So that's why we have to organize ourselves. As per HTM, we have to prepare a utility shutdown, and here the utility is medical gas system. And be sure, please, that concerned department has signed this request, because they have they are responsible and accountable with medical gas individual or department as well. Again, why we have chosen HTM? Because HTM said we have to use medical gas pipeline permit to work or work permit. depends on the hazard, whether high risk or high hazard or low hazard, and everyone should sign it. High hazard, we use it once we have a new line, new project, new extension. We have to shut off the pipe and construct a new extension. While low hazards is only once you just change or replace the outlet by a new one. It's low hazard. After that, prepare a form, test form signed by the contractor or by the individual and by the witness who is the biomedical engineering or maintenance or whatever. The concern standard is FMS 32. The hospital ensure proper maintenance of the medical gas system. Before starting, there is a rule we have agreed with our friends, our colleagues in CBAHI, MOH, and Civil Defense, and Saudi FDA. There was a representative. We have agreed on this rule where we have to see a system, not cylinders. It is mandatory for healthcare where we have high consumption rate, active operation rooms or theaters, where we have emergency departments, we have trauma room, ventilators, etc. Why it's not mandatory for specialized hospitals like eye center, eye hospitals, like mental health or convalescent hospitals. 31.1 medical gas system is regularly tested for the pressure link functionality of the valve. This we should have it in LOX tank, in pump room, and we have to check even the area valve service unit, the valve of medical gas, to check the pressure, whether it's acceptable or not. And 31.2 talking about the policy. The policy should list all these, which include taking any part of the system offline, commissioning and testing, and new branching, ordering, and how to order or filling the liquid tank, and all repairs or alteration tests should be recorded. This is a sample in area valve service unit where we are getting the readings, where it should be at least 4 bar in medical air. We found it 2.5. It does mean we have a leak, for instance. This is valid for vacuum and for the nitrogen side and medical air as well. Compressed medical air is literally tested for humidity and purity and humidity. First of all, medical air testing should be done in 2 locations, at the compressor and the outlet. Should be same criteria. If there's different, it means we have a problem. Sorry. How to test the humidity? By a humidifier like the one have from Fluke company or another one, we can measure it. But for purity, there is a device, we call it medical gas analyzer. It's a little bit expensive, between 60 to 80,000. It's okay if you can hire it or call someone to do your work. That's it. Actually, here we got questions, frequent questions. How frequent we should test the compressed air for humidity and purity? Actually, let me explain by details. In HTM, there is no frequent period mentioned. Every 3-4 months, it's not mentioned. But HTM stated we should test compressed air in case of a new line, replacement of outlets, and replacing filters or changing filters in the plant room. So how to control it? It's very difficult to control it. I cannot ask the hospital, okay, give me the date you install a new line. Based on it, we have to check your testing of humidity and purity, or when you have replaced the outlet, or give me the date you change the filter. It's complicated. So that's why we have agreed with our colleagues in hospitals and in CBAHI surveys as well, that let's make it quarterly to make sure that hospitals are doing it. And it's easy, by the way. In HTM, the medical air, giving us the parameters in terms of the oil, water, CO, CO2, odor, and etc. So this is the value that we have to see. If it exceeds more than it, so the means the medical air purity is not acceptable. Even for the concentration, the HTM give us a reference to test the concentration of the oxygen. Sometimes we have a very long piping system, so that's why you can measure the concentration of oxygen. Like instance, in the source could be up to 99.5 at the cylinder or at the LOX tank. But in the outlet in patient room should not be less than 94. And FBA or the American standard or reference maybe 92 or 93. And this was one reason that we have chosen HTM. It always gives us the stronger criteria. 32.4, the central medical gas station is in safe and secure place. Should be locked all the day, or there is a technician available 24 hours, especially to monitor the alarm system on the control panel while transfer from lux to the manifold and from right manifold to the left manifold. This slide is very important actually, because we get so many questions about distances for liquid oxygen storage between 20 to 1 to 5,000 liters away from the hospital, away from the public roads, away from flammable gas system, etc. 32.5, the outlet of medical gas are clearly marked with the type of gas and have different connections. And actually, we recommend in CBAHI to use the DIN standard. DIN standard in outlet, I mean the German standard in choosing the outlet, where there is no chance to install a probe in a wrong outlet. However, once we visit hospitals, we check the outlet, the marking of outlet, and we ask the nurse to check to test the gases by using flow meters, suction, oxygen, and etc. Actually, I have intentionally put this slide because it's a disaster for us and for the hospital to see that hospitals are using outlets that are being forbidden to use. For instance, the left photo, medical air, don't use outlet system under test, and they are using it, and they did not remove this sticker. They are not remove this sticker means maintenance or testing were not being done. The other photo is this point must not be used because under testing, for instance, danger, and they are using. So please remove this sticker after maintenance or after testing or after replacement. All medical gas pipes are clearly marked and labeled, and the direction of gas flow, like this one. Frequent question is how frequent. Actually, it's from 3 to 5 meters. Maximum is 5 meters. This is to allow technician to recognize the pipe, whether it's oxygen or nitrous oxide or whatever. We have talked at the start the presentation that we have an accident because of cross connection. And this is what happened. The technician over the floor ceiling cannot recognize the pipe of the oxygen, and consequently he installed a new pipe with different or wrong type of gases. So that's why 5 meters, you have enough distance to recognize the type of indigo gas. We came now to the stock cylinders. How to prove that hospital has stock cylinders enough for 48? We put actually an equation. It's not accurate 100%, but it works with you. Because calculation or transfer the liquid oxygen to gas is very complicated, and there is so many parameters to calculate it improperly 100%. That's why we have done this equation for you. It's approximately, it's accurate more than 95%. So just please consider that 1 liquid oxygen liter liquid is equal to 855 liter of gas at 20 degrees Celsius. And 1 K-size cylinder, the K-type, equal to 6,800 liters of oxygen at 2,000 psi, pound per square inch. So if you have log system, you can calculate it, or if you have K-system, K-size gases, you can calculate it. At the end, we have to see a signed document showing the average oxygen consumption as a liter, gas liter, okay, in the hospital, compared with the cylinders you have. Should be minimum 8 to 4 hours. The gas cylinders are regularly tested for gas type, amount, and any leak. Actually, we are getting frequent questions. Since we are receiving these cylinders from the supplier, from the factory, why we should test it? As a matter of fact, a few years before, we informed the supplier in our region that anti-NOx, which is used in labor and delivery, I think, percentage should be 50% oxygen and 50% nitrous oxide. We found it by our tools that it's 48 and 48. And we informed the supplier, informed the factory. Actually, the in charge in the factory made fun of us. He told us, who are you to talk to me? I am the factory of such gas. However, after 1 week, we received an appreciation letter from the factory stating that thank you so much. We sent our tools to Italy for calibration, and we found the percentage you are told us is correct. We are very sorry. So based on that incident, actually standards were put based on the actual incidents. And since then, we have added this condition that once you receive a batch of cylinders, please use your at least oxygen analyzer to measure or to identify the type of the cylinder. I know we have tag from factory. It's okay to test it and document it. Every time you receive a batch, just randomly test one type, one cylinder, please. 32.10, emergency shut-off of valves should be available with area showing the marked with area and room affected. As you see here, we have add a tag on the area valve service unit, mention the coverage area. For instance, in this slide, this AFCU covering the radiology department, to CT scan, to X-ray, whatever, okay?
نأسف على انقطاع الصوت. سيعود إلينا المهندس نوار بعد قليل. احنا الحقيقة استلمنا عدد من الأسئلة. We received several questions regard of the head count of the manpower of what we gave here is guidelines. You need always to refer back to these guidelines, benefit from it in order to be in the safe side in terms of providing a safe environment. I think Engineer Nawar is back with us now. Engineer Nawar?
Yes, sorry, there was a disconnection in our internet. I don't know from which slide it was disconnected. This one or the previous one?
Can you go back to the previous slide, please?
Sorry.
Also more back.
This one?
One more back again. Okay, yes, you finished this. So the next slide, please.
Okay.
Okay.
We have explained to you that why we should test regularly the cylinders we receive from the supplier. Since it has a tag, the cylinders have a tag while we are testing. And I explained to you that a few years before, we tested one cylinder by our medical gas analyzer, and we found that anti-NOx cylinders is not 50% oxygen, 50% nitrous oxide. It was 48-48. And that's why we informed the supplier, and supplier or the factory sent the tools in the factory to Italy for calibration, and he sent us an appreciation letter with his apologies. So that's why since ever, we put this standard that once we receive a batch from the supplier, please randomly choose one cylinder and test it by oxygen analyzer to know the type. FMS 32.10, we should have marked the shut-off valves and with area covered or room affected. For instance, in this slide, this area valve service unit covered radiology department, for instance. Plus, the hospital should dedicate responsibility of the closure of shut-off valves to well-trained individuals available in unit concerns. During our visits to hospitals, we do not stipulate who will be that individual because it depends on the hospital policy. Most of hospitals assign nurse manager or charge nurse to be responsible. And we are telling them, please don't pick only one person. Okay, the priority for number one will be charge nurse, but put second one, third one in case she or he not available or he is engaged in fire incident, Allah forbid. However, we found one of the hospital assigned 5 person or 5 entities, including treating physicians, nurse call, RT, respiratory therapist, emergency response group, and fire chief of civil defense. There is nothing wrong, nothing correct. It depends on hospital policy. An example from remote or area hospital, just imagine the A2 valve, O2 oxygen is open and located in public area. And there was some children playing there. Just imagine, Allah forbid, if a child or someone closed the valve and this valve connected to the ICU. We have to avoid all such cases. 32.12, hospital has adequate medical gas outlet. Here we have 2 references. Please choose one of them. The right side mentioned in facility guidelines, which is related to ASHRAE, I think, and the left side related to HTM, as mentioned. Both are acceptable, but usually in CBAHI we recommend HTM. Okay, we are done by medical gas. Mr. Mohsen, any comments or questions?
There was a question regarding where should be the location of HEPA filter in the operating room. Is it inside or outside the room? Fresh air ducts. So if you can elaborate in this.
Yeah. Yes, sure. For operation theater, usually we should have a system and backup system. For instance, if you have one AHU for two operating theater, please have an additional one as a standby HEPA filter, usually located over the operation table on the supply. And the fresh air, as mentioned before, fresh air in the operation theater percentage is 20%. And we should have a 20 air change per hour in the operation room. Mr. Mohsen?
Yes, thank you. There is another question in regard of what is the time required for area valve leak tests and the frequency of medical gases tested.
Yes, for medical gas, ppm should be every 6 months. For ppm, it's 6 months. For testing of cylinders, at every batch you receive, you have to test randomly one cylinder. Hopefully this is clear.
Yes, excellent. Again, another question in regard of the utility failure drills. How a drill can be conducted and what will be the lesson learned from doing utility failure drill?
Okay, we have utility system failure plan, and you have a plan B for each system. This, what you wrote in your plan, you have to apply it as a scenario, as a drill, exactly what you have wrote in your plan. In case of failure of power, what you are doing, you will send someone to generator, inspecting the ATS, inspecting the batteries, everything, like what you are doing during the interruption. So what you have wrote in your plan, please do it as a drill, as a scenario, but do not disconnect the power. This is the only difference. Like the fire drill, we don't set a fire, we assume there is a fire. Prepare a form, write the date, the attendees, technicians' attendance, what was the scenario, what was the action, was the action taken properly as per the policy, and your comment as a facility manager or facility director. Hopefully this is clear as well.
Absolutely right. You cannot find how reliable is your system unless you test it. As you know, we are testing the generators on a monthly basis with load. That means we disconnect the normal power and have our dependent in the generator. So we make sure that in case of emergency, God forbid, you will not lose important areas from support. The same will apply to other systems. Actually, for some systems, you cannot measure even your consumption from medical air. For example, if you are not using cylinders, if you are using unless you do this exercise and drills, so you will know your consumption rates. If we do have any further questions that we didn't, some questions have been answered during the presentations. Most of the answer was answered during Engineer Nawar presentation. However, If you do have any additional questions, we would be happy to answer. Okay.
Actually, our colleagues in CBAHI head office will collect all your questions in an Excel sheet, and they will forward it to us to answer it later on, and they will announce about the link if it's settled.
Okay, I have a question. How can the leak tests for cylinders be done?
It depends on the pressure, actually. The pressure can show you whether there is a leak or not.
Yes, that's right. The pressure. We received questions in regard of some cylinders looks old and has some scratch, and will that affect infection control precautions? Or will it be accepted to receive a rusty cylinder or a cylinder that has some scratches?
Actually, it happened maybe last year in a hospital. They complained to the supplier, to the factory, and they fix it. Actually, they replace it. We hope that hospital could push the contractor or the supplier not to bring such cylinders, scratches, color is demolished or something. The hospital should take care of such issue, actually. As I said, we cannot say something about it, but the technician should take care of such problems.
Absolutely, and as agreed, the hydro tests for cylinders has to be done by the factory every 5 years. And they should issue a certificate saying that this cylinder has undergo a hydro test. You can keep the cylinders that are tested, but the shape is not in the workshop area and the manifold area, while cylinders that you take to units, you take care that they are meeting infection control requirements and does not pose a danger, God forbid, if someone had get into contact with or scratched to it.
Absolutely, you are right.
We thank you for joining us during these past 4 days. We hope that you have benefited or cleared some information that you needed before. We hope we received a lot of questions regarding how to get into access to these presentations later. I'm sure CBAHI will answer this to all participants. Thank you so much again. Wish you all the best from my side. I don't know if Engineer Nawar has additional points to elaborate at.
No, it's okay. Thank you, Mr. Mohsen. It was a nice chance for us to talk to all concerns individuals, and we are happy to answer your answers in CBAHI standards anytime. You are most welcome. نستودعكم الله في أمان الله والسلام عليكم ورحمة الله وبركاته.